Alright, so today we're going to be talking about remainder and factor theorems. We spent some time yesterday going through and doing some factoring review, and I think you will find throughout this process that you're familiar with a lot of the concepts that we are addressing. So, this first example, we have f of x equals 2x squared minus 3x plus 4. You're asked to find f of 2 using synthetic substitution. Now, basically what synthetic substitution means is that I'm doing the process of synthetic division that we previously talked about, but instead of it giving it to me in the form of x minus a number or x plus a number, it's just giving you the number that you need to put on the outside. So here, I'm going to take 2, on the outside, making sure all of my coefficients are accounted for. So we have x squared, x, and then our constant term. So we line all of those up. 2, negative 3, and 4. Remember that we bring down our 2 to begin with, and then we multiply back up. So we have 2 times 2, which is 4. Adding in between these two rows. So negative 3 plus 4 gives me 1. 2 times 1 is 2. Adding gives me 6. So now you have synthetic substitution. F of 2 is equal to 6. That value is your remainder. If we use the process of direct substitution to see whatever the function would be when x is equal to 2, then we would just plug in 2 times 2 squared minus 3 times 2 plus 4. So here we get 8 for the first term minus 6 plus 4, which is equal to 6. So our answers are the same. So in this case, we're going to use f of 3 in the following function with synthetic substitution. So we put 3 on the outside here. All of your coefficients accounted for once again. So 4, negative 2, and 7. Bring down your 4 to begin with. 4 times 3 is 12. Negative 2 plus 12 gives me 10. 10 times 3 is 30. Adding those two together, we get 37. So this part right here is what I'm concerned with. And that means that f of 3 is equal to 37. Again, if we were to check that by direct substitution, plugging that into the function, we have 4 times 3 squared minus 2 times 3 plus 7. So we have 36 minus 6 plus 7, which is equal to 37. So, when synthetic division is used to evaluate a function, like in the previous two examples, it's called synthetic substitution. Remember that there are cases that some terms could be missing. So in this case, we have 3x to the 5th, then we skip down to a negative 4x cubed plus 5x minus 3, and we're asked to find f of negative 3. So first of all, we want to make sure that all of our terms are accounted for. So I need a placeholder for that x to the 4th term that's missing. My negative 3 goes on the outside, just like normal. Then we start with 3, plug in a 0, go down to negative 4. Here we go straight from x cubed to x, so we also need a 0 for the x squared term. Then x is 5, and my constant term is negative 3. Following that process of synthetic division, we have 3 times negative 3 is negative 9. 0 plus a negative 9 is negative 9. Multiply back up, that gives me a positive 27. When I add those two together, I get 23. 23 times negative 3 gives me negative 69. Then we multiply again to get 207. 5 plus 207 is 212. And then 212 times negative 3 is negative 636. So when we add those, we get a negative 639 on the end down here, which means that f of negative 3 is equal to negative 639. Okay. So what does all of this mean in relation to polynomials that we've been talking about? Well, we have something called the factor theorem, which says that the binomial x minus a is a factor of the polynomial f of x if and only if f of a is equal to 0. So meaning, if I were to substitute in that value, use synthetic substitution to solve, and I get a remainder of 0, then that means that it's a factor. So your next example, if you flip your page over, is x minus 2, a factor of x cubed minus 3x squared minus 4x plus 12. So what I want to know is, do I get a remainder of 0 when I use the synthetic substitution process? Remember that if it's in the form of x minus 2, this is x minus a. So a is equal to 2, which means we're going to put a positive 2 on the outside there. Bringing down all of your coefficients, this time I have 3, 2, 1, and then the constant term for each of my degrees. So everything is accounted for. Whoops, this first one should be a 1. So we have 1, then negative 3, then negative 4, then 12. Bring down your 1 to start with. 1 times 2 is 2. Negative 3 plus 2 gives me negative 1. Negative 1 times 2 is negative 2. Adding those gives me a negative 6. And then negative 6 times 2 is a negative 12. So when we add those, we get a remainder of 0. Yes, that means that x minus 2 is a factor. Now, if you'll remember back to when we did synthetic division, we took all of these coefficients to figure out what was left over if we were dividing by x minus 2. So you drop your degree by 1, which means that this starts with a 1x squared minus x minus 6. So this would be what was left over if we divided out x minus 2 from this polynomial. Now we want to know if we could find the two remaining factors. So here's where that practice that you did yesterday with factoring should come in handy. We have a trinomial, so we're looking to see if there's anything that multiplies to be a negative 6 and would add to be a negative 1. So in this case, our factors of 6 would be 3 and 2, and we would need this to be x minus 3 and x plus 2, so that way we come up with that negative sign in the middle. So then all of your factors of this polynomial would be x minus 2, x minus 3, and x plus 2. Now, we are given a polynomial and one of its factors, and we are asked to find the remaining factors of the polynomial. So we start with all of our coefficients here. 1, negative 1, negative 17, and negative 15. Go ahead and bring those down. On the outside this time, we have an x plus 3 as our binomial, which means that the number should be a negative 3 on the outside, because this is x minus a negative 3. Okay, so we bring down our 1. We have 1 times negative 3, which is negative 3. Add those two together, you get negative 4. Negative 4 times negative 3 is 12. Adding those two, you get negative 5. And then negative 5 times negative 3 gives me 15. So this is 0. Okay? Notice in the question that it said you were given a polynomial and one of its factors. So if you took this value and used synthetic division and you did not get a 0 here, you want to go back and rework what you did. Because if you are given a factor already, they're telling you x plus 3 is the factor, then you should get a remainder of 0 here on the end. So once we have that remainder, what's left over is x squared minus 4x minus 5. So again, we look to see if it will factor. Something that multiplies to be negative 5 and adds to be negative 4. We only have one set of factors for 5. That's 5 and 1. In this case, we need an x minus 5 and an x plus 1 to make that a negative 4. So x minus 5 and x plus 1 are the two remaining factors of the polynomial. So we'll do one more example like this. We've got x cubed minus x squared minus 5x minus 3, and the factor is x plus 1. So again, we have all of our coefficients accounted for, so we just have to bring them down. 1, negative 1, negative 5, and negative 3. Then on the outside, this is a plus once again, so we have x minus a negative 1, meaning that negative 1 is going to go on the outside. Bring down your 1 to start, so 1 times negative 1 is negative 1. Adding these two together gives me negative 2. Negative 2 times negative 1 is positive 2. Negative 5 plus 2 is negative 3. Negative 3 times negative 1, positive 3. When I add, there's my remainder of 0 on the end. So here's the three terms I'm left over with. I have x squared minus 2x minus 3. So that trinomial is going to factor again. So we've got an x minus 3 and an x plus 1 as our two remaining factors. Now, this next one, we have a polynomial, one of its factors. Find the remaining factors of the polynomial. Once again, check for your degrees. It looks like the squared term is missing here. So we're going to have 1, then we're going to have 2, a 0 as a placeholder, then negative 8, and negative 16. On the outside, we put our negative 2. Bring down your 1 to start the process. So 1 times negative 2 is negative 2. Add together, we get 0. 0 times negative 2 is 0. We add, we get 0. Multiply, we get 0. And then negative 8 plus 0 is negative 8. Negative 8 times negative 2, 16. Add those two together, we get our remainder of 0. So now let's take a look at what's left. We have right here an x cubed minus 8, because this is our x squared term, this is our x term. There's nothing there for us. So that means that our factors, we have to factor this one using difference of cubes, which I know is one of your favorites. But if you'll remember the formula that I gave you, it's a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So all I need to know is what the cube root of each of those two terms is. So a is going to be equal to x, and then b is going to be equal to 2. So writing it in this formula, I get x minus 2 times x squared plus 2x plus 4.